So actually, what is a Zookeeper? So Zookeeper actually is it's a coordination service which is a Apache open source project, and Zookeeper actually helps you to build distributed applications. So if you want to build a distributed applications, you don't need to write from the scratch. So that's why, like most of the maybe product companies, or maybe if you want to build a distributed application, so you can choose the pre-existing Zookeeper APIs to build your application. You don't need to write everything from the scratch. And where exactly the Zookeeper services are used for? For example, you need to maintain configuration information across your cluster, then you can use Zookeeper service to maintain that configuration information where multiple nodes or multiple computers, they want to access that information, and that will be maintained by the Zookeeper service. So all the integrity is maintained by Zookeeper, and you don't need to worry about multiple requests coming in through multiple different computers, and you need to do all those balancing and everything. Next example is like the name nodes. If you want to have a name node, you can build it using Zookeeper service. For example, next one is the distributed synchronization. Like when you want to write data across different uh, data nodes, you can use the like Zookeeper service for synchronization. So you don't need to worry about how that locking, queuing of all this requested across distributed applications will be done. So that will be taken care of by the Zookeeper. The last one is like the last one is the group services like leader election. So suppose you have a master slave type of architecture where you want to implement uh, a dynamically selection of a master when some master is down. So you can build that type of application using Zookeeper as well. So Zookeeper is distributed, it's reliable, and it's fast and simple APIs. So you can use those APIs using Java and C to build distributed applications. So going to the next slide, this is the architecture looks like. So this is the Zookeeper service, and it has a leader, and then you have all these, you can call it slave nodes, and then what happens is that when the Zookeeper service runs, this whole box is called ensemble, and when this runs, it dynamically selects one leader among that particular ensemble box. And then if suppose this goes down, so it will again select one of these automatically. So you don't need to worry about the high availability in Zookeeper. And all these are client machines, so they can connect to one of each servers, and everything is synchronized across Zookeeper, and all the synchronization, locking, everything will be managed by the Zookeeper. So it provides, that's why it provides high availability and consistency, and these servers, they know each other, what they are doing, so any request comes here, so will be propagated across the ensemble, and that will be written in by the Zookeeper service. And these clients always connect to one Zookeeper server. They cannot connect to multiple. So they can send a request to one server, and that request will go to the leader, and that will decide on where the exact processing will happen. So some of the usage or use cases of Zookeeper service is in HBase. So HBase uses the Zookeeper master election service and other coordination between the servers. Then in the MapReduce world, the higher availability of the resource manager is also implemented using Zookeeper. Then in IBM Big Insight, this is one of the like your MapReduce framework by IBM, just like MapR, Hortonworks, or Cloudera. So they also improve. They also use Zookeeper service for their IBM Big Insights product. The last one is for Flume. Flume is also using the Zookeeper service for configuration purpose. So that's from my side, and I will ask a very easy question. So in case of you write, in case you need to write a distributed application, so whether you want to go for writing it from scratch or you want to explore Zookeeper.
Zookeeper.
So everybody will get a candidate. Okay, thank you.